Okay, so today we're looking at highest common factor and lowest common multiple. And so the first thing we want to look at to understand this essentially is what a factor is. So a factor of a number is basically any number that goes into it. So for example, if we want to write the factors of 20, then what we'd have to write is any numbers that go into 20. So you could do this manually. You can make a list. Okay, 1 goes into 20, 2 goes into 20, 3 doesn't, 4 goes into 20, 5 goes into 20, 6 doesn't, 7 doesn't, 8, so on and so forth. You can write down all the factors of 20. Okay, now what is a factor then? Essentially we're saying that 2 multiplied by some whole number will give us 20. Okay, so in this case it's 10, so that would be another factor we can write over here. 4 multiplied by some whole number, in this case it would be 5, would give us 20 as well. Okay, so these are all factors. 1 multiplied by 20 would give us 20 as well. So these would all be what we call factors of 20. Now we can do the same thing for multiples, and let's actually use a different number. So if you want to work out multiples of 5, multiple of 5 is basically anything in the 5 times tables. So 5, 10, 15, 20, so on and so forth are all what we call multiples of 5. And often in maths, what we want to find out is things that have common factors or common multiples. So if you have 2 different numbers, can you write down all of the common factors and can you write down all of the common multiples? So one thing that we might be asked to do in maths is to write a number as a product of its prime factors. So here are all the factors of 20. So what do we mean by a prime factor? Well, essentially a prime factor is any factor of a number. So for example, something like 20, any of these factors which are prime numbers. So remember, a prime number is a number that can only be divided by itself and by 1. We don't usually count 1 as a prime number, even though it technically can only be divided by 1 in itself. We generally just don't count it as a prime number. So 2 would be a prime number because it can only be divided by 1 and itself 2. The next prime number in this list is 5, because 5 can only be is only divisible by 1 and itself 5. It doesn't have any other factor. And so one way to find the prime factors of numbers, you can list out the factors and then basically select which ones are prime numbers. But generally we can get some quite big numbers, so we want a better way to do that. So essentially what we can do is make a factor tree. So let's take for example number 12, and we want to make a factor tree from this. So what we do is we think of any number that goes into 12. So any factor of 12 that we can think of. So straight away I can think of 6 and 2. So these are both factors of 12 because 2 multiplied by 6 gives you 12. So you make a tree like this, and what we'll notice straight away is that 2 is a prime number. So straight away we've got one of the prime factors, which is 2, but 6 is not. 6 can further be broken down. So next you want to work out, okay, what are some factors of 6? And straight away I can think of 2 multiplied by 3. So you write it down like this again, and what we notice is now we've got prime number here 2, and 3 is also a prime number. And so if you want to write 12 as a product of its prime factors, then what we'll write is 12 is equal to 2 multiplied by 2 multiplied by 3. So you break down the number until you get all of the prime numbers, which are the roots essentially. Basically write it out like this to write out as a product of its prime factors, and you also write this out as 2 squared multiplied by 3. That's the same thing. And so why do we bother actually breaking out a number into its prime factors? Well, the reason is it makes us finding the lowest common multiple and the highest common factor of 2 numbers much easier. So first of all, what do we mean by the term lowest common multiple? Well, essentially we're saying if you have 2 numbers, for example, 4 and 6, then you want to find a number that is in both of these times tables, basically, and you want to find the lowest possible number that is in both of these times tables. So one way you could do that is to list all of the multiples of 4 out. So 4, 8, 12, 16, 20, 24, and so on and so forth. And then you could do the same thing for 6. So the multiples of 6, you just list out the 6 times table. 6, 12, 18, 24, and etc. And so you can see the common multiples that 6 and 4 have just from our list here is 12. Both of these have 12 in it, and both of them also have 24 in it. And as the case may be, we're looking for the lowest common multiple. So the lowest out of these numbers is 12. And so the lowest common multiple of 4 and 6 is 12. But as you can imagine, if we have 2 really large numbers, this could be much harder. Let's say we have 250 and 300. Now, things could get quite complicated, and we might have to go and make this list on for a long time. And so you might not know your 250 times tables, and you might not know your 300 times tables. You could have more complicated numbers, let's say 12 and 17, and you want to find the lowest common multiples. It's quite difficult to list out all the multiples of 17 and all the multiples of 12 until you find 2 that are the same. So we want to have a better method to actually solve these. And so one thing we can do is use the prime factors, or write these 2 numbers out in the form of product of their prime factors. So let's take an example here where we want to find the lowest common multiple of 12 and 15. And so to list all of these out could take a while, all of the multiples out. So instead we break both of these down to the form of the product of their prime factors. So basically we break down 12 first. So 12, we've already done this, so we'll just repeat it quickly. So we have 2 and 6 here, and then 2 and 3 here, and then all the numbers are prime numbers, so we stop there. 2, 2, 3. And so as a product of the prime factors, we write 2 times 2 times 3. Nice and simple. So we can do the same thing for 15. Let's take 15 over here, and 15 we can break it down to 5 and 3, and so 3 is a prime number, so we'll stop there, and 5 is also a prime number, so we stop there. And so we can see 15 written as in the form of a product of its prime numbers would be 3 multiplied by 5. And so once you're at this stage, what you want to do is draw a little Venn diagram. So essentially what you can do is have the factors of 12 on this side and the factors of 15 in this circle, and basically anything in the middle are factors which are present in both 12 and 15. So for example, for 12, we know we have a 2, and a 3, but 3, because 3 appears in both of these, we're going to put 3 in the middle. And then we know that the other factors are for 12 are 2 and 2, so we can put 2 down twice over here. And the factors of 15 are 3 and 5, but 3 is already in the middle, so we just put 5 in here. So essentially what we're saying is that in the pink circle on this side, basically, the factors of 12, which are not factors of 15, are included. In the green circle, not counting the middle, the factors of 15, which are not also factors of 12, are included. And in the middle, you have the factors of 15 and 12. So any factors that appear in both lists, in this case, 3 and 3. And so our answer basically is then you just multiply all of these together. So you do 2 multiplied by 2 multiplied by 3 multiplied by 5. So when you multiply all of those together, you should get 4 times 3 times 5. So 4 multiplied by 15, which should give you 60. So the lowest common multiple of 12 and 15 is therefore 60. And instead of listing it out, we use the prime factorization method. Now that might take a bit of getting used to, so I'm going to give another example which you guys can follow along with. So let's find the lowest common multiple of 60 and 72. So the first thing we want to do is break each of these down to the product of prime factors form. So let's take 60 first of all, and straight away I can think of 10 and 6, and then let's break down 10 further. So 10 can be broken down to 5 and 2, and you can see here we've got 2 prime numbers, so we'll leave it at that. And 6 can be broken down to 3 and 2, so again we've got prime numbers there. So these are the prime factors of 60, and so we can write it out as 5 times 2 times 3 times 2. Excellent. Now we do the same thing for our next number, 72. Let's write it over here. So 72 broken down to the prime factors. So the first thing I can think of is 8. So 8 and 9. And then we can further break down 8 to 4 and 2. And so that's a prime number, so we leave it there. And then 4 can be broken down to 2 and 2. And those two are prime numbers, so we leave it there. And then we break down 9 to 3 and 3, and those are both prime numbers. So our product of our 72 written as the product of its prime factors would be 2 times 3 multiplied by 3. And actually there's another 2 over here. I forgot to include this 2 over here. So make sure you include all your 2's. And then the next stage then is to draw a Venn diagram of all our factors. Pink circle over here for 60 and green circle over here for 72. And the first thing we want to identify is all the factors which are common to both, which will go in the middle. So you can see both of these have 2 2's in them. So we can cross these out, put them in the middle, 2 and 2. And they also both have a 3 in them. So we can cross the 3's out and put a 3 in the middle. And what's left for the pink side is just 5. And what's left for the green side is 3 and 2. Great. So now we can work out what our product of prime, so now we can work out what our lowest common multiple is. So essentially we just multiply all of those together. So 5 multiplied by 2, multiplied by 2, multiplied by 3, multiplied by 3, multiplied by 2. Or in other words, 5 times 2 cubed multiplied by 3 squared, which is the same thing as saying 5 times 8 multiplied by 9. 8 times by 9 you should know is, so 5 times 72, which is equal to 360. So the lowest common multiple for 60 and 72 would be equal to 360, and we worked that out using the product of prime factors form. So let's do the same thing now for highest common factor. Hopefully everyone understands that for lowest common multiple. And so for highest common factor, let's actually go ahead and use the same numbers. Why not? So we want 60 and 72. We want to find out what's the highest common factor. So the highest number that goes into both of these numbers here. So once again, let's break it down to our product of prime factors. So let's use 2 different numbers now. Let's use 12 and 15. So we want to find the highest number that goes into both of these. So let's break it down to the product of prime factors form again. So 12, 3, and 4. And then we need to break down 4 further into 2 and 2. So you can see that breaks down nicely. The next thing we can do is do the same for 15. So 15 breaks down to 3 and 5. And then these are both prime numbers. Okay, great. So now once you're at this stage, once again, you can draw out your Venn diagram. So the first thing again is what goes in the middle. So both of these have 3 common So we can do 3 and then cross the 3's off. And then what's left on the factors of 12 is 2 and 2. And what's left for 15 is 5. But actually, we don't really need the 5 and the 2 and 2. In any case, what happens is that the highest common factor is whatever is in this middle circle here. So in this case, it's just 3. There's just one 3, so it's just 3. If, for example, in the middle, we use two different numbers, let's say we had 2 and 6, then our highest common factor would be 2 times 6, which is equal to 12. Okay, this case is just 3, so we say 3. Okay, so nice and easy for highest common factor, a little bit simpler than lowest common multiple. But let's have a go with a few questions now, practicing on both of those. Okay, so these are the quiz questions. Feel free to pause the video and have a go for yourself, and then come back for the answers. Okay, so let's get into it. For the first question, then we want to find the highest common factor of 34 and 20, first of all. So let's write it down here, 34 and 20. And so the first thing we're going to do is break these down to the product of prime factors. And so 34 broken down to its prime factors is the following. So you can see that 2 goes into this and 17. And 17 is a prime number, so we'll leave it there. The next thing is 20. And so 20, we can break it into 2 and 10. And 10 breaks down further to 5 and then 2. And then these are both prime numbers. And so we can then draw our Venn diagram. And again, remember, we're looking for the highest common factor. And so all we're looking for is basically the numbers in the middle. And so you can see 2 goes in the middle because it's common to both of them. And we can fill out the rest, but we don't really need to because we're just looking for highest common factor. So the highest common factor for both of these is just 2 in this case. Okay, so let's do the next one. The next one is got 12 and 14. So we can break it down again. So 12 broken down, we've done this number a couple times already. I'll just do it quickly. 6, 2, 3, 2. And we do the same thing for 14 over here, 2 and 7, and 7 is a prime number. And so you can see the Venn diagram, you might be able to do it in your head now. And in your Venn diagram, in the middle, we should got just 2. So the highest common factor of 12 and 14 is 2. Question then, part C. The numbers we have are 175, 220, and 1200. And it's exactly the same approach when you have 3 numbers. All it is now in your Venn diagram, there'll be 3 circles, but again, you're still just interested in whatever is in the middle for all 3 of those. Okay, so as usual, our first step is going to be to break it down into the prime factors. So 175 broken down to its prime factors, I can see 5 would go into this, and 5 would go into this 35 times. And then we want to break down 35 further, so we can see 5 goes into this again. That goes in 7 times, and then we've got 3 prime numbers there. So that's 75 done. Then we can do 220 over here. So for 220, let's work out the prime factors. So first I can see 2 goes into it, so that 2 and 110. And then 110, we can work that out. 2 again, and 55. 55, we can break it down 5 and 11. And 11 is a prime number, so we got all our prime numbers there. 220 done. Next one is 1200, because even with big numbers, we can break it down to prime factors quite quickly. So we can see straight away 2 goes into it, and that would become 600. And again, 2 goes into it, that becomes 300. And 2 goes into it, that becomes 150. And we can keep going. 2 goes into it, so that becomes 75. And with 75, we can say that 5 goes into it, so that becomes 15. 15, 5, and then 3. So those are our prime factors for 1200. So now we've got the prime factors 175, 200, 220, and 1200. And remember, for the highest common factor, we want to find out what goes in the middle of our Venn diagram and go from there. And so when you got a lot of factors like this, it's useful to write it in the indice form that we saw earlier. So here for 1200, we can say that this is equal to 1, 2, 3, 4. 4 2s, 2 5s, and 1 3. So this is 2 to the power of 4 because you've got 4 2s. You've got 2 5, so multiplied by 5 squared, multiplied by 3. And we can do the same thing for 175 and 220. So this is 5 squared times 7, and 220 is 2 squared times 5 times 11. Okay, so then when we go to draw our Venn diagram, it's a little bit easier. So let's zoom out, and I'll just do the Venn diagram over here. Right, so we want to write down everything that's going to go in the middle. So all of the factors are common to 175, 220, and 1200. So you can see they all have a 5 in them. And 175 has 5 squared, 220 just has 5, whereas 1200 also has 5 squared. And so you can see the only thing that we're going to put in the Venn diagram is 1, 5, okay? Because 220 only has 1, 5, we won't be able to put 5 squared. So instead, these would just become 5. We just decrease the power by 1 because we only got 5. Instead of having 5 times 5, we just have 5, okay? And that's the only common factor to both of these. You can see 175 doesn't have any 2s in it. And so once again, our highest common factor is just going to be 5, okay? But like I said, depending on what's in the Venn diagram, you just multiply it together. That's what you do. Right, let's go through the least common multiple questions then. So the first one is find the lowest common multiple of 6 and 13. So I'll just do it over here. So 2a, so you want 6 and 13. And so again, we can break it down to the product of prime factors. So 6 breaks down to 2 and 3, nice and easy. And 13 itself is a prime number, so we don't need to break it down any further. And so you can say basically that the lowest common multiple of these is, well, when you do your Venn diagram, is when you multiply all the factors together. Now in this case, our Venn diagram is really simple because none of the prime factors are common. So basically you'd have 13 over here, and you'd have 2 and 3 over here, and nothing in the middle. So basically you'd get just 2 times 3 times by 13 to work out what your lowest common multiple is. So that's 6 times 13, which is equal to 78. Cool. And we'll do the next one here, part B, 700, 1500, and 3000. And so let's work through this. So let's break this 700 down to the prime factors first. So this, you can see, goes into 2. This becomes 350, 350 once again over 2. This becomes 175, 175 again, well this time it can go into 5. This becomes 35, 35 go into 5 becomes 7. And so you can see we now have everything in the prime factor form. So then let's do the same for 1500, use a different color. So once again though, same exact method, 2 and 750, and then that becomes 2 and 375, and then that becomes 5 and 75, and then that becomes 5 and 15, and that becomes 5 and 3. Also, that is that one done, and then we can do 3000 as our final one. So let's break this one down. Exact same method, that becomes 1500, and you can see you've already done 1500, so you can basically just repeat whatever you wrote there. It's the same factors. Okay, cool. So now we have all of our prime factors written out. We can simplify it to write it in a slightly easier to work with form. So for 700, you've got 2 2s, 2 2s and 2 5s and 1 7. So you can write it as 2 squared times by 5 squared times by 7. For 1500, we can see we've got 2 2s, 3 5s and 1 3. So you can write this out as 2 squared multiplied by 5 cubed multiplied by 3. And lastly over here, we have 3000, and it's basically the same 1500 just multiplied by 2. So with an extra 2 in there, it becomes 2 cubed multiplied by 5 cubed multiplied by 3. And sorry, I've just made a quick correction to the 3001, and so actually we missed out one breakdown here, so that should be 1 2 3 5s and then 3 2s as we mentioned, and a 3 as well. Okay, so it is, like we said, the same as the previous one with an extra 2. 2 cubed times by 5 cubed times by 3. So now we've got all our factors written out like that, so we can draw our Venn diagram. So there's the first one, there's our second one. In fact, I'll do that in black to make it less confusing. And finally we have blue. So let's go through and put the numbers in. So we can see in the middle straight away, we do have 2 squared in everything. So this has got 2 cubed, but this can be broken down into 2 squared times by 2. Okay, so we have a 2 squared in all of these. And so essentially what we'll put in the middle is, and essentially this becomes, instead of 2 cubed, you get rid of 2, cross that off, so it's just 2. So it's just 2 multiplied by 5 cubed multiplied by 3. So in fact, we'll actually rewrite that. Then we can see both of these have at least a 5 squared common to both of them. So you can see that's got a 5 squared. So let's cross these off, sorry. So that's got a 5 squared. This has got a 5 cubed, so which is essentially the same as writing 5 squared times by 5. And so basically this just becomes 5, cross out the square. And same thing over here. This is 5 squared multiplied by 5, so we just leave the 5 squared in there. Okay, and that's it for the common factors. These two both have a 3, but this third one does not, so we can write 3 in this box over here, cross it off. These two both have a 5 remaining in them, so we can write a 5 in here. You can make your diagrams a bit bigger to make it easy to squeeze in, so now we can cross these two 5s off. And so this just became 2, remember, so we just got a 2 left here that's going to go in the bottom here. The pink one is done, so this 1500 is done, and then just what we had left for 700, which was 7. So 7 goes in over here. Okay, so hopefully that makes sense in terms of how we did that Venn diagram. You just start off with what's common to both, and if it's easier you can write these all out. We just left it in our indice form, but if it makes sense more to write them out, then there's nothing stopping you from doing that. So then we want to find the lowest common multiple. We just multiply all of these together. So 7 times 2 squared times by 5 squared multiplied by 5 multiplied by 3 multiplied by 2. Okay, which is equal to 7 times 2 squared multiplied by 5 cubed multiplied, 2 cubed multiplied by 5 cubed. multiplied by 3. And you can put that into your calculator to find the lowest common multiple. And so you should get an answer of 14,000. Okay, so that is your lowest common multiple. And that's how you work it out. You can see with these big numbers, it's much harder to do if you were to just write it out. And that's why we do need to actually go ahead and do this extra step of finding the prime factors. Okay, so that is lowest common multiple and highest common factor and how to work them out using the product of prime factors form. Hopefully you found that video useful, and I'll see you guys in the next one.